In this video, I'm going to show you 7 examples of adding and subtracting radical expressions. The first thing I want you to know is that before you can add or subtract radical expressions, the number under the radical needs to be the same. Once that number is the same, then you can collect like terms to get to your answer. This first example, I have already set it up where the number under the radical is the same. Because the number under the radical is the same, we can combine these two as if it was 4x minus 2x, which is 2x. We can pretend that the radical 5a is a variable, and so this problem, 4 times the square root of 5a minus 2 times the square root of 4a is 2 times the square root of 5a. Okay, let's try that again. Okay, this time, again, the radicals are the same, and so we can add them together and then keep that same radical. Right here, when doesn't appear to be a number on the outside of the radical, there's always an invisible one. So 1 square root of 8 plus 5 square root of 8 is 6 square root of 8. And then the final step is I want you to check to see if 8 can be simplified. This is the factor tree of 8. There is a pair of 2's, so we can bring a 2 to the outside. There was already a 6, so 2 times that 6, the square root of 2 is 12 square roots of 2. Let's talk about what if there's not the same number under the radical. So these last few problems are all going to be those type of problems where the number under the radical is not the same. The first thing I want you to do is I want you to make a factor tree of both radicals. Pause the video and go ahead and make the factor trees for both of these radicals. Okay, now that you have the factor trees, we are going to simplify each radical. We'll do them one at a time. This first one has a pair of 2's and a pair of n, so the inside is going to stay 2m. The outside is going to be 2n. The next one, there is a pair of 3's. Notice that there was already a 2n on the outside, so this is going to be 3 times that 2n, which is 6n, radical 2m. Since both of these radicals are the same, we can combine these two together and then keep radical. This final answer is 8n times the square root of 2m. All right, go ahead and pause the video and make 2 factor trees of both of these radicals. Once you have your factor trees made, I want you to circle groups of 2 and then rewrite both of these radicals. The first radical has a pair of 3's and a pair of c's. There was already a b on the outside, so we'll put those letters in alphabetical order and say 3bc square roots of 5c. The second radical has a pair of 2's and a pair of b's. There was already a 4c on the outside, so this is 8bc times the square root of 5c. Because these radicals are the same, and because both of these outside numbers have the same variables, we can collect like terms to get 11bc times the square root of 5c. All right, here's another one. Again, same thing. Go ahead and pause the video and make out your factor tree. Here's what your factor tree should look like. Now go ahead and circle pairs of numbers. There are your pairs of numbers. Now go ahead and rewrite each of these radicals. Because there's a pair of 5's, notice there was already a 4, so this is 20a squared, square root of 2, minus 7a squared, square root of a, minus 7a squared, square root of 2. Hopefully you're starting to see a pattern. Because the radicals are the same and because the numbers on the outside have the same variable, you can combine like terms. 20a squared minus 7a squared is 13a squared times the square root of 2. Okay, these last two are the hardest that you're going to see. For me, this is combining 3 radicals together. Pause the video and make a factor tree for each of these radicals. Okay, this is what your factor tree should look like. The next thing I want you to do is I want you to rewrite each of these radicals by circling the pairs, and then notice each of these do have a number on the outside. So go ahead and pause the video and rewrite each one of these radicals. Once you've rewritten the radicals, you should have the expression 3x times the square root of 6 minus 4x times the square root of 5 plus 6x times the square root of 5x. I want you to notice something, that these two terms are the same, but it does not match the first term, and that is okay. We can combine these second terms to be a positive 2x square roots of 5x, and then we can just bring down the 3x times the square root of 6, and that's your final answer. This is the last problem of the video. Again, this is what I would consider one of the hardest ones to work through. The first thing I want you to do is pause your video and make out the factor trees. Now that you've made out the factor trees, I want you to rewrite each radical by finding the pairs and multiplying it with the number on the outside. Please pause your video and rewrite the radicals. Okay, this is what your radicals should look like once you have pulled out the pairs and multiplied them to the outside. A few things I want to point out. Notice that each radical has the same number underneath, and each radical has the same variables on the outside. Because those two things, the same number under the radical and the same variables on the outside of the radicals, we can combine these numbers together. Negative 4xy plus 3xy is a negative xy minus 8xy is negative 9xy square roots of 3x. That's all for this video. Please reach out to me if you don't quite understand these problems. There's more practice problems on Moodle. Feel free to watch this video again. Thanks so much.